Hi there, this is Muhammad Anjum, and in this video I will share a step-by-step guide for deploying a geolocation API on Google Cloud's Cloud Run, in how to set up and automate the deployment of a FastAPI Python application to Cloud Run, which is Google Cloud's serverless containers platform. To learn more about how various components interact within this project, you can watch the Building Geolocation API video, where I walk you through the code and explain the design and concepts in a bit more detail. However, for an overview, the project has 5 distinct components. A FastAPI application that handles web requests and queries IP addresses to retrieve geolocation data from MaxMind GeoLite2 databases. A Docker file that automates the process of downloading the GeoLite2 databases and building a lightweight Docker image. A cloud build.yaml file that defines the necessary steps for the build pipeline, which includes building the Docker image and deploying a new revision to Cloud Run. A CDKTF application that deploys the required cloud infrastructure for the API using CDKTF, that is Cloud Development Kit for Terraform. A deploy.sh shell script that orchestrates Cloud Shell environment setup and deployment of Cloud Run service and the required cloud resources. For the purpose of deployment, we will only be executing our shell script, which will take care of setting up our environment and deploying our CDKTF application. However, before we run our script, we need to manually do a few things. Before we begin, let me give you an high-level overview of the steps involved. We will start with getting a MaxMind Developer Account to obtain a license key. This key will be used in our Docker file to download latest GeoLite2 databases. Then we will log into our Google Cloud platform and create a new project. Then we will fork and clone the repository so that it is available in our GitHub account. We will connect our GitHub repository to Cloud Build trigger to use it as a source. We will use .env file to customize and configure our environment. Finally, we will execute our deploy.sh shell script, which will set up our Cloud Shell VM and then deploy our Cloud Run service. Let's begin by going through each item on this list one at a time. First step is to create a MaxMind account. To set up automatic database updates within our container image, we need to create a MaxMind account to obtain a license key. To sign up for a MaxMind account, go to the MaxMind website and fill out this form to sign up for access to GeoLite2 databases. You will then receive a verification email. Check your email and click on the link to set a password for your account. Once you have set the password, log into your MaxMind account. MaxMind will send you a verification code to your email. Copy and paste the verification code to complete the authentication process. Once you're logged in, on your account dashboard, click on Manage License Keys in the left sidebar. Click on Generate New License Key and enter a name for your license key. Then click Confirm to generate your new license key. Keep this window open as we will come back to this shortly. First step is checked. Moving on to the next one. Next step is to log into your Google Cloud account. Before we begin, please make sure that you are logged into your Google Cloud account and have a valid billing account. You may be charged for using Google Cloud services, but Google Cloud's free tier is more than enough to test our deployment without incurring any cost. The free tier includes a set of Google Cloud services that you can use for free up to a certain usage limit. If you exceed the limit, you will be charged for the additional usage. If you do not want to continue using the service, our CDKTF implementation makes it very easy to destroy the deployed resources with just one command. To log into your Google Cloud account, go to the Google Cloud Console page. Click on the Sign In button. enter your Google account email address and password, then sign in. Once you're logged in, you will be taken to the Google Cloud Platform console. From here, you can start using Google Cloud services. To create a Google Cloud project for deploying our geolocation service, follow these steps. Click on the Select Project button located in the top left corner of the GCP console. Click on New Project to create a new project. In the project name field, enter geolocation. Make a note of the random project ID that Google Cloud assigns. This is required to be unique globally, so Google Cloud assigns a random number to the name. Click Create. Click on the Select Project button and select the newly created project to make it the active project. You can also select the project by clicking on Select Project drop-down button located in top left corner of the GCP console and then selecting the project. So creating Google account project checked. Next is to fork and clone our Git repository. Okay, to fork the Git repository, first go to the GitHub repository page. Then click the fork button in the top right corner of the page. This will create a copy of the repository in our own GitHub account. Once the repository has been forked, click the clone button. In the clone with HTTPS section, copy the URL of the repository. Open the terminal window in our Cloud Shell environment. Then clone the repository using the URL we just copied. The repository will be cloned to our Cloud Shell environment. Okay, so repository is forked and cloned. Next is to add a connection to this GitHub repository. In this step, we authenticate and connect to Cloud Build trigger. To connect our GitHub repository to Cloud Build, go to the repositories page in the Google Cloud console. We will have to enable the Cloud Build API first to be able to use this feature. Scroll to the bottom of the page and click Connect Repository. Leave the region as global and make sure GitHub is selected. Then click Continue. If you are not already logged in to GitHub, you will be prompted to do so. After signing in, GitHub will prompt you to grant access to your GitHub account. Click on Authorize Google Cloud Build by Google Cloud Build to accept and allow Cloud Build to access your repository. Once you complete the authorization flow, you will see a list of your repositories, including our newly forked repository. From the list, select the repository to establish the connection. Do not create a trigger yet. We will do it using CDKTF. Now repository is connected. Next, we update the .env file. Our CDKTF stacks depend on values from .env file for setting up our infrastructure. To set up .env file, follow these steps. First, activate the terminal window in Cloud Shell. Wait for the Cloud Shell session to open. Then open the file editor. Next, locate the example_env.txt file from the navigation pane and copy its content. Then create a new file and paste the copied content. Save this new file as .env in our project root, which is the cloned repository git directory. Once saved, update the project name variable to reflect your project name. Then locate the random ID that was assigned by Google and set it to random_ID variable in our .env file. Next, set your preferred Google Cloud region to variable region_preferred. If you will be using this API from a front end, set the FastAPI underscore CORS underscore origins variable accordingly. The FastAPI allowed hosts variable allows access to our API only from specified hosts. Initially, we can use an asterisk to allow all hosts. Once our Cloud Run service is deployed, we will obtain the specified URL. We can update the .env file later to include the URL of our Cloud Run service. Then set the URL of your forked repository. You can replace these dashes with your username and make sure not to add .git at the end, as we have already connected the repository. If we add git here, this will create one more connection. Then go ahead and open the page where we had created our MaxMind license key. Locate the account number and the license key and update those variables in our .env file. Be sure to remove any unwanted spaces after the equal sign or after the variable value. Our .env file is now configured and we are ready to deploy our Cloud Run service. In this final step, we execute our deploy.sh script. In order to learn what our script does in detail, please refer to Build Geolocation API video. From a deployment standpoint, in a fresh and clean Cloud Shell environment, our script will first prepare our Cloud Shell VM and then deploy our CDKTF stacks one by one. When I initially started working on the project, I began documenting the steps to write a detailed guide for setting up the Cloud Shell VM to deploy our microservice. However, I realized that most of this work can be easily automated and a simple shell script would be more beneficial and user-friendly for everyone involved. Consequently, I went ahead and created a shell script that handles the setup and deployment of our foundational CDKTF stacks. We then had to trigger the build manually once before we could deploy our third and final stack to deploy our Cloud Run service. In this version of the script, I was using PyEnv to set up Python version globally, and there were a couple of manual steps to be taken in the exact order at a particular point in time. This was making it a little difficult to understand and troubleshoot. So I spent some more time to refactor and make the script better, and the result was fully automated end-to-end deployment of our microservice Geolocation API in just one command. To execute the script, activate the Cloud Shell terminal and make sure you are in the project root directory and run /deploy.sh script. If prompted, select authorize to continue. Now sit back and watch our Cloud Shell VM get set up and our Cloud Run service get built, tested and deployed on Cloud Run. This script actually does a lot of work, and to understand more, please watch my video about building Geolocation API, where I walk through the code and delve into how various tools work together and how this shell script brings everything together. It should take approximately 12 minutes for setting up VM, building the container image, and then deploying a Cloud Run revision. The playback speed of this video is set to 8 times the normal speed. At this stage, we should have a running Cloud Run revision for our geolocation service. To check the status of our deployed Cloud Run service, go to Cloud Run Services console page. You should see our deployed Cloud Run service. Click on the service link to get details of the Cloud Run service. Locate the URL and click on the link to go to URL. You will get a response that the get method is not supported. Now edit the URL to go to OpenAPI docs URL and explore the available endpoints. Also, check for our configured weekly schedule to trigger our cloud build. So every week our cloud build will get triggered and rebuild the image with updated MaxMind GeoLite2 databases and deploy a new Cloud Run revision. It took quite a bit of work to reach here, but from now on automation will take over. Our weekly cloud scheduler job will make sure that the container image gets rebuilt with updated MaxMind database and a new revision gets deployed every week. Now we can use this API in any number of applications that needs geolocation information. We do not have to worry about keeping the databases up to date or the scalability of the service. Cloud Run by design will spin up as many containers as required based on the demand, and when there is no demand, Cloud Run will terminate all containers and scale the service down to 0. We are built only for the time our containers are serving requests. I hope you enjoyed the video. Make sure to leave a comment. Your feedback and suggestions are very important to me. Please like and subscribe and enable notifications to get notified of new content. Thank you so much for watching. See you in the next one.